Are high-speed trains the future of American transportation? When federal funds were allocated to upgrade the nation's rail network, it appeared so. But with Congress's recent decision to discontinue funding for the High-Speed Intercity Passenger Rail program, supporters of the initiative must now refocus their efforts. Would Americans ride high-speed rail? How much would it cost? And where should it be built? These are some of the questions more than 5,000 high school students faced when they competed for over $100,000 in scholarship prizes in the 2012 Moody's Mega Math Challenge.
So we split these costs into two main categories. I think it's helpful just to see what applied math really is. Most people think math is this theoretical concept. It's a lot of numbers and variables. But when you think about it, it's more of a process than anything else. It's a way of thinking about the world.
The M3 Challenge is organized by the Society for Industrial and Applied Mathematics and funded by the Moody's Foundation.
Nothing delights me more than having a student tell me, it never occurred to us you would ask a question like that, and now I can really see how I can use math for anything.
Previous challenge problems have focused on a variety of topics, including the U.S. Census, alternative fuel sources, and a drought in the Colorado River Basin.
Our problem was to analyze these regions and figure out whether or not it would actually be worth developing these high-speed trains.
I thought that the U.S. needed high-speed rail, and I wanted to see if it was a possibility. So I was really interested in seeing the results, because in any applied math question, it's very rare that you actually know the answer. You have ideas, but you want to see what other people think.
We were totally caught off guard with the high-speed rail, but it was a really well-written question. There were a lot of opportunities for us to come up with creative ways of addressing the problem.
The annual competition is entirely internet-based, and there are no fees to participate. On the challenge weekend in March, teams see the problem for the first time when they download it from the web. Then, in just 14 hours, they must put together a detailed solution paper and upload it back to the contest website.
We started off brainstorming, which was really good, but then we had to go back and regroup several different times, and by the end of the day, it was very, very hectic trying to fit everything into the 20-page limit, which was also pretty difficult.
Our engineering courses really helped us to think outside the box. For example, when we were figuring out the cost for the rails, we had to get fairly into the technical nitty-gritty of, well, how do we construct a rail line?
We started all together as a group looking for background information about what's HSIPR, what are these zones that it's looking at, and then we split up into two groups.
We submitted our paper with only 21 seconds left. It was intense. To the very last minute, we were formatting it to get it into 20 pages and trying to send it.
Next, in a rigorous judging process, panels of professional mathematicians spend weeks evaluating hundreds of entries, eventually selecting just 6 of the teams to present their solutions at the competition finals in New York.
Seeing as there are 961 teams and there's so many teams that go through the judging rounds, we thought we didn't really stand much of a chance, but we were shocked and we were also really proud at the same time.
Congratulations. Your team's entry was judged to be in the top 1% of the almost 1,000 entries in the 2012 Moody's Mega Math Challenge.
We said that the fraction of inner-city commuters in A that go to B is proportional to the population of city B.
As you can see, California is the most profitable region, while the Gulf Coast and South Central regions will never be profitable.
The ridership equation is proportional to a population function.
This cost was multiplied by the total number of stations, and this gave us the total cost for that section of the railway.
A train going more than 125 miles per hour can't exactly corner a hairpin. This is a very challenging prospect indeed.
These reductions are significant because they can slightly lessen America's dependence on foreign energy.
Despite the fact that we all know how important math is, politicians are always going on and on about it, the general public thinks of mathematicians as slightly geeky, and these people are not geeky. They're great. They're very articulate, they're very thoughtful, they've done an important job.
When I would hear people saying, oh, I want to major in math, or I'm a mathematician, I'd think, oh, so you work with chalkboards all day. But now I see that math is exciting both in and of itself and as a tool to explore other fields.
The winners of the 2012 Moody's Mega Math Challenge, High Technology High School, Team 286 from Lincroft, New Jersey.
The goal of the M3 Challenge is to raise awareness of applied mathematics as a powerful problem-solving tool, a vital contributor to society, and as a viable and exciting profession.
By going through the experience of really looking through a lot of different data, thinking about different ways that you can model things, really gave me a different perspective about the power of math and how it can really be incorporated into everyday life.
It was a really great experience to be able to work on such an open-ended problem with so many people who had similar interests and similar talents to you. We all came from different backgrounds, we all had different perspectives and shed different light on different issues, but when it came together, I think we made a beautiful product.